EPOXIDES.com.
Okay, students, now we are going to start. Now we are going to start with the ethers. Okay, what we are going to start? We are going to start with the ethers. Okay, so ethers we are going to complete in one lecture itself. It may take time, but I will make sure that you will be able to understand it completely. Okay, so now let us start one by one right from the basics. Okay, so initially the simple topics will be covered so that you should not have any problem in understanding. Okay, for the board level, right from the board exams to the IIT advanced examination, like there are some special topics. There are some special topics like cyclic ethers, okay, crown ethers, uh, epoxides, okay, those are all also covered. Okay, in between I will try to give you some tips so that you can answer the question very fast. Okay, so here first of all let us start from the very basics. Ethers, what is the definition and how they are classified? Okay, ethers are compounds having general formula ROR. Okay, so R stands for here alkyl group. What does it R stands for here? Alkyl group. Okay, one oxygen surrounded by two alkyl groups are known as ethers. Okay, now these ethers are classified. Classification means differentiation, separation. Ethers are classified into two types. Ethers classified into how many types? Two types: simple ethers and mixed ethers. Okay, so if these two groups are same on oxygen, if the both groups are same, then they are called as a simple ether. Even sometimes it is also called as symmetrical ether. What they are called as? Symmetrical ethers. Okay, and aryl means benzene and its derivatives are called aryl, and hydrocarbons are called as alkyl. Okay, mixed ethers are called as a unsymmetrical ether. Mixed ethers are called as unsymmetrical. Both groups attached on the oxygen. If this is R, this will not be R. This will be something R dash. Then they are called as ethers. Unsymmetrical ethers are mixed ethers. Is that clear to all of you? Ethers are divided into how many types? Two types based upon the type of alkyl groups attached, type of aryl group. If both alkyl or aryl groups are same, then it is called simple ether. If they are different, then they are called as a mixed ethers. Okay, after the definition of ethers, after the uh, classification of ethers, next topic we are going to study is structure and hybridization. Structure and hybridization. Okay, structure also can be written as what? Shape. Okay, here what is the shape? V. Okay, V sometimes they may change the language. They will give as a bent structure. Sometimes they may change the language. They may write as a angular. Okay, it is not necessary that always they will mention shape of the ether as a V. They can mention as a bent shape, or they can mention as a angular shape. Structure, is it understood? And hybridization, here hybridization is of the oxygen. And what is the hybridization? sp3 hybridization. Okay, so there is a trick. I told you I will tell you the tricks and some important questions from the previous examination. So let it be any hour. It may take long time also, because covering the entire chapter, it may take time, but what you have to do, you should not lose your interest. Okay, so trick is number of sigma bond and lone pair you add. Okay, so here one sigma bond, two sigma bonds. Okay, and one lone pair here, one lone pair here, so two lone pair here. Total how many are there? Four. Okay, so what you should start? You should start from the S and total 4. To make 4, you have to take 3 p orbital. Hybridization of oxygen will be sp3 hybridization. Hybridization of oxygen will be what? sp3 hybridization. Okay. So is that clear now? We have studied about the definition part. We have studied about the classification part. We have studied about the structure and hybridization with short trick. Okay. Okay, next topic is naming. So people are worried about that which type of naming. Okay, so they need not to ask only IUPAC name. They can ask common system naming also. Okay, so earlier they used to write like this. This is also ethyl. This is also ethyl. So they totally written as a diethyl, and this oxygen is written as a ether. This is a common system, old system, obsolete system. Nowadays, this system is not used. But don't take risk, learn the previous system also. Okay. So here also methyl and methyl. So both are methyl, therefore dimethyl, and this oxygen is ether. So this is okay for which type of? These two are which type of examples? Symmetrical ethers are, these are the example of simple ethers. Okay. But there can be unsymmetrical ethers like this. Okay. See, some side C2H5, some side methyl. Now you will follow the alphabetical order. Okay. E starts with first E and methyl starts with E and methyl start with M. So E comes first, therefore ethyl first its name, then second name, then suffix will be ether. Okay. This is the common naming. Sometimes they may ask common naming also. That's why I have explained the common naming also. I think it is clear. Okay, next, as per the IUPAC name, they are named as a alkoxyalkane. Okay, so alkoxy, that means methoxy, and alkane, methane. So this is a substitute basically. Okay, what this is written as substitute, this is the main chain. Main chain is also methane, substitute also methane. Okay, but we have the different function group. The longest alkyl group will be written in the suffix, smallest with oxygen will be written in the prefix, methoxyethane. Understood? Now you can check here. Here it is consisting 3 carbon atoms. Here it is consisting of 1 carbon atom. So this will go in the prefix. Smaller will go in the prefix. Larger will come in the suffix or word root. Okay. So this is the propane. Now very important thing, anisole. Okay. Anisole is very important. Simple. It is a benzene ring. Okay. Now it is cyclohexane. Now it is benzene ring and OCH3. This is called as anisole. Like this names, what you will do, you will write 2 to 3 times. Okay. Then if I write here in place of the methyl as a ethyl, then IUPAC name will be ethoxybenzene and here it is methoxybenzene. But in the common name, it is very famous, phenetol, okay, and anisole. So phenetol and anisole are very important common namings, okay. So they may not ask in the IUPAC name. They are so famous that they will definitely ask in the common name only, anisole and phenetol. Rest all you can need not to worry. You know IUPAC system, you know common system. There is no problem in that. Okay, but problem lies only when they are famous with the common naming itself. Okay. Okay, after definition, we have done definition, we have done classification, we have done naming. Then done naming in how many parts? 2 parts, IUPAC naming and common naming. And in common naming, very important names are anisole and phenetol. Now let us do about the isomerism. Okay, ether shows 2 types of isomerism. How many types of isomerism? 2 types of isomerism. Functional isomerism. Functional means functional group must be different. Okay. So suppose if we write C2H6 oxygen. Okay. What is the name? C2H6 oxygen. With them, if I write both side methyl group and center oxygen, now it is ether. But if I write C2H5OH, now it is alcohol. So alcohol as well as ether, both are having same molecular formula. Both are having same molecular formula, but different functional groups. Therefore, they are called as a functional isomers. Okay. Then metamerism. Metamerism means functional group should be at the center, and on the either side alkyl group must be different. Okay. So let us take C here. Ethoxyethane. What it is? Ethoxyethane. Here it is ethyl group, but if I write like this, are they both are same? No. Here it is ethyl group, here it is methyl group. And here it is ethyl group, and here it is what? Propyl group. Okay. So these two functional groups, alkyl groups, are not same. So that type of isomers are called as metamers. Okay. Metamers means have same molecular formula, but alkyl groups attached on the either side of the functional group must be different. Okay. So this is also an example. Okay. So here it is isopropyl and it is methyl. Okay. Isopropyl and methyl. So like this, there are how many types of isomerism they are showing? They are showing the two types of isomerism: functional isomerism, and next one is the metamerism. Okay. Okay. Now after completing the basic regular topics, normally what you will do? Preparation methods. Okay. So preparation methods, the very first and most important. In this one, there are very two important examples. What are those two examples of preparation methods? I will tell you at the end of that, but don't neglect in between. Okay. If you skip at least one sentence, it is going to create a problem in further understanding. And last part is very very important part. Okay. So dehydration, D means removal, hydration means water. Water must be removed. Okay. So here it should be dehydration of alcohol, but it should be bimolecular. What it should be? Bimolecular. Bi means two molecules. Okay. Here I have taken this one molecule, this one molecule. Dehydration, water must be removed. So for removal of water, one will lose H, another will lose OH. Okay. H and OH will form as what? H2O. Okay. And this RO and this is R. So they both are forming as a ROR. That is what our ethers are prepared. Understood? But here these two things are very very important. Who will do all this job removing the water? Who will do concentrated sulfuric acid will do our job. Okay. But temperature is also very important. We have to maintain 140 degrees Celsius. Okay. 140 degrees Celsius. If we use the sulfuric acid, okay, when two molecules of alcohol undergoes dehydration in presence of concentrated sulfuric acid, we have to maintain 140 degrees Celsius, where two molecule will lose only one water molecule. Okay. And if we change the catalyst now, okay, so actually sulfuric acid is a dehydrating agent. Okay. It will lose the water molecules. It will remove the water molecule. We can replace the concentrated sulfuric acid with Al2O3. Okay. And then temperature will be changing. What is the temperature here? 250 degrees Celsius. Reaction is same. Products are same. Reactants are same. But if I change in the presence, sulfuric acid can do the same job at 140 degrees Celsius, but Al2O3 requires a high temperature of 250 degrees Celsius. Are you able to understand? Okay. Okay, as I told you, there are certain two important topics. That out of two important topics, one topic is Williamson synthesis. Okay. If anybody wanted to make tough question from the ethers, okay, then it is the best and most frequently asked question, Williamson synthesis. Even it may come in the board examination. How they will ask in the board examination? Write a short note on Williamson synthesis. Okay. So in the board examination, presentation matter. What will matter? Presentation matters. Okay. You should write it in a nice language so that the paper correction person should understand it easily. Okay. So Williamson synthesis is a preparation of. Williamson synthesis is a preparation of what? Very good. Preparation of ethers by treating alkyl halide, okay, with sodium alkoxide. With what? Sodium alkoxide. With sodium alkoxide in presence of ether. In presence of ether. So Williamson synthesis, if you have to write the short note, what you have to write? Williamson synthesis is preparation of ether by treating alkyl halide with sodium alkoxide in presence of ether. Understood? So this is the Williamson synthesis preparation method. And we will do some question session. Okay. Organic is very best while you studying. Okay. But problem comes how to use that what you have studied in the examination, how to solve the question what you have studied in the class. Okay. So for that only which came introduced as question session. Okay. After learning the theories thoroughly, actually what you will do, first you will attend the class with mind. These are all should be, whatever I am teaching, that should be uploaded into your mind. Okay. After that, what you have to do, suppose 1 hour, 1.5 hour lecture. Then in that, what you will do, again you will log in back and you will take the screenshots. What you will do, you will take the screenshots of all these. Then you will write with your own handwritten notes. Okay. Then you will be eligible for our question session. Okay. So once you attend and understand the concept, then you will write in your notebook with the screenshot. Then definitely 80% efficiency will be there in the question session. Okay. So I think all of you will do that. Spend some extra time daily. Some suppose 8 to 9 is your self-study time for chemistry. Then you will do either of this job. Okay. You will take the screenshot and write notes. If you have already written notes, then you will go through and remember. Then you will start solving questions of that topic. Okay. That is the only way you will score better in the organic. Understood? So daily 8 to 9, I hope all of you will do the chemistry revision, chemistry study, and either it can be before the dinner only, best time. Understood? And then you can use our channel regularly. Daily it should be a regular schedule in your life till the time you reach to your success. Okay, this is commit to memory. Commit to memory in the sense there is less to study but more to remember. Okay, so this is not much useful for those people, those who are happy to clear the board exam only. This is for them, those who wanted to explore the things, some crack some difficult examination. Okay, so then, but Williamson synthesis is very must. Okay. So heating alkyl halide. This is a alkyl halide. Okay. So again here you will take how many moles? 2 moles of alkyl halide with silver oxide. Okay. So here I will tell you the memory technique. This is the oxygen. Okay. On the either side this will be Ag. On the either side it will be Ag. Okay. And here it will be Cl. And here it will be R. Okay, here again it will be Cl, here it will be R. Okay, now you have to be a cut it like this. Okay, cut it like, what is that hero picture name? I don't remember. Bahubali. Okay, you should be like Bahubali. You should cut it nicely like this. Then see what is left over, ROR. Okay, so that means our ether is formed. So this is what AgCl. This is another AgCl. So 2 moles of AgCl. Okay, heating alkyl halide with silver oxide. Silver oxide will react with how many moles of alkyl halide? What will be the answer in integer type? 2 moles. Okay. 2 moles of alkyl halide react with 1 mole of silver oxide. It should be dry. Okay. What it should be? It should be silver oxide must be dry. Okay. So then only this ether will be formed. Okay. Then from alcohol by the action of diazomethane. Okay. So here if you know the internal meaning, then next time you will not forget. Di means two. Okay. Di means what? Two. Azo means nitrogen. Methane means first carbon. See, diazomethane, CH2N2. Okay. Diazomethane when treated with ROH. Understood? Simply, this CH2 will go and attach here. Then what it will form? ROCH3 plus N2. But this will take place in presence of fluoroboric acid. What is the name? Fluoroboric acid, HBF4. Okay. And there is a limitation this. There is one limitation to this method. Can anybody guess? What is the limitation of this method? What is the limitation of preparation of ethers by the alcohol with diazomethane? Limitation means you can prepare only one few type of compounds. What are the type of compounds we can prepare by the alcohol method with diazomethane? Who will answer? Okay, very good answer. Answer is this can be used only for preparation of methyl ethers. We can use only methyl here because this is diazomethane. This is suitable only for the preparation of methyl ether. Here you can keep any type of alkyl group, but this side it should be only one methyl group. Okay, that is the limitation. Okay, next method, same diazomethane only. Example here we have taken from phenol. Okay, same thing happens. This CH2 will go attach here. CH2 and H, what it will be? CH3. And reagent also same, fluoroboric acid. Nitrogen will be produced. So what is the name of this compound? What is the name of this compound? Very good. ANI. Very good. Anisole. Okay. So this is the preparation method of anisole. Okay. And excellent method is Grignard reagent method. Excellent method is Grignard reagent method. In this one, Grignard reagent, I think all of you are aware. If not aware, at least RMGX is the general formula of the Grignard reagent. Okay. So here I am using always make sure that it should be dry condition. What should be the condition? It should be dry in condition. So what you can expect now out of this which will go outside? Out of this which will go outside? Yes, this X will go with Mg. Mg, X and X. This will be what? MgX2. And this R dash will attach here. Okay. So I will write it clearly here so that you can understand in a better way. ROCH2X. Okay. Now this MgX I will write it like this. R dash MgX. R dash MgX. Okay. Now the things will cut like this. So first product will be ROCH2R dash and second product will be MgX2. Okay. So this is the way you will prepare ethers by this method from the Grignard reagent. Okay. So Grignard reagent is used in the Ascent series. Which series? Ascent series. Okay. What is Ascent series? What is Descent series? That we will study in the conversion. There will be a separate lecture for conversion which are highly useful for the board exams and advanced examination. In mains there are less chances, but advanced they will definitely ask a question like paragraph. Okay. So that we will solve it separately. Okay. These are the some important preparation method. Okay. Now special method. This is only used for vinyl ethers. What is vinyl? This is called as a vinyl. Okay. I think you have studied in the polymerization. Okay. PVC pipes. PVC pipes means P means poly, V stands for vinyl, and okay, C stands for chlorine, polyvinyl chloride. Okay, PVC pipes. Vinyl means this functional group, sorry. This hydrocarbon or this group is called as a vinyl group. Okay, suppose if I write OH, then it will be vinyl alcohol. Okay, if I write chlorine, then it will be called as a vinyl chloride. Understood? So if I substitute OR in this, then it will be called as a vinyl ether. Okay, vinyl means, is it understood? This group is called as CH double bond CH2 is called as a vinyl. Whoever you are substituting, that will be the name added. Vinyl chloride, vinyl ether, vinyl alcohol. So for that, what we will do, first we will take ethine. Okay, triple bond is there. That's why it is in ethyl. Simply what it will do, it will add itself. Okay, hydrogen will be added here. Sorry, hydrogen will be added here, and this oxygen will be added here. I will make it clear. Okay, this oxygen will be added to this carbon atom. This hydrogen will be added to this carbon atom. So this triple bond will become as a double bond. RO is attached to CH, double bond CH, and one hydrogen came from here. It is CH2. Is that simple English? Is that understood? So I normally use very simple English so that you should be comfortable in understanding, and you should be better to write them as it is in the examination also. Okay, now we have studied the preparation methods. What we have studied, we have done the preparation method. Okay, just we will go through the short revision. Okay, so special method, vinyl method. Okay, then before that, from phenol and Grignard reaction, and before that, heating alkyl halide with silver oxide and diazomethane got a limitation. Were very important, Williamson synthesis, and before that, dehydration of alcohols and catalytic dehydration of alcohols. Temperature is different here as catalyst is changed. Concentrated sulfuric acid is changed now. Okay, so like this, these are all the things we have studied. Now let us start with the properties. Okay, we have started with some basic concept, and we are reaching to the advanced concept very slowly. Okay, so properties, dimethyl ether and ethyl methyl ethers are gases. Okay, only starting two ethers are gases, and others are highly volatile. Volatile in the sense they can evaporate easily. Inflammable, they catches fire very fast, but slightly soluble in water. Definitely there will be a reasoning question, especially for the NEET people and state board engineering examination, like MSET, KSET, okay, and TS set, like that, TS MSET, like that. They will ask why ethers are less soluble in water. Okay, because they cannot form intermolecular hydrogen bonding. Suppose this is a alcohol, so this can also form hydrogen, this can also can form hydrogen bond. Okay, but if it is a ether, only who can form, this cannot form, this cannot form, only oxygen can form. See here, if you compare here in the alcohol, double chances are there. In ether, only single chance is there. That's why slightly soluble. In that slightly also, ether oxygen forms the hydrogen bond with the water molecule, that is called as a intermolecular hydrogen bond. And for advanced examination or mains examination, 2 decimal place accuracy, 1.18 D dipole moment. Okay, I think all of you will remember that. Now let's go to the next one. Okay, next, after the preparation, then properties. Okay, so these are called as a general properties or general reaction, GR. Okay, general reaction, I will write it in short so that maximum time we should spend on the questions. Ether when reacted with HCl forms oxonium salt. Okay, this is called as a oxonium. Okay, if it is chlorine is there, oxonium chloride. If sulfate is there, oxonium hydrogen sulfate. Okay, So simple, ethers are bases. Okay. Actually, ethers are why they are base. Why they are base? Which type of base they are? Ethers are which type of bases? Ethers are Lewis bases. Ethers are which bases? Lewis base. Because in the structure itself, I told you there will be two lone pair. So because of this lone pair, they are Lewis bases. Okay. So base plus acid, what it will form? Salt. Base plus acid will form salt. Okay. And sometimes they will form the peroxide also, but with nascent oxygen. This is called as a nascent oxygen. So one of the lone pair of oxygen will be donated to the atmospheric peroxy formation. Okay. This is how there are some properties. Okay. Okay. Next thing I told you, there are two important topics. Okay, for the mains, for state level, for board exam. First one is Williamson synthesis. Okay, and second thing is reaction with HX. In that also most important reaction with HI. What is the most important reaction with HI? Okay, so these are the very must and should topic right from the board exam to advanced exam. Advanced topics are some extra that topics I will cover in the end of this session. Okay, so RX plus R dash OH. Okay, so this is alkyl halide, this is alcohol. When treated with concentrated HX, it will form RX plus H2O. Okay, so when one alkyl group is tertiary group, see this is a ether, this is methyl, this is tertiary group. Okay, this is tertiary group. Then halide formed by tertiary halide. Okay, so main problem is that iodine will go here or here, no doubt. Okay, so according to when alkyl group is tertiary, this is what called as a tertiary. Tertiary means 3 degree. So in that condition, this first rule says that iodine will go to the tertiary carbon atom. Okay, tertiary carbon atom, and this hydrogen will go and attach here itself. So CH3OH. Is that clear? So X always attaches to the small r reactivity of HX. Okay. So HI greater than HBr greater than HCl. Is it understood? So in this example, if it is a additional rule. Okay, what is this? This is additional rule. Other than this, X attaches to the smallest. Okay, whereas here X and R. Okay, X attaches itself to the small, and higher will attach to the R dash. Okay, so this is about the cleavage by HX. We will do some questions according to this. Okay. Okay, next slide also very important. Mechanism. Okay, as I told you, mechanism is important for the board exam. Okay, first step is protonation. This is the ether. This is what? Ether. Okay, now our HI, I have taken HI as an example. This is proton, this is negative charge. Okay, this is negative charge. What is this? This is negative charge. Now this lone pair will be accepted by the hydrogen. Okay, so now this oxygen, see here how many 3 bonds are there with one lone pair. Because of the 3 bonds and one lone pair, now it is having the positive charge. Okay, so now iodine is free now. First step, what it will form? Hydrogen. Hi hydrogen will accept lone pair from the ether. Then iodine will attack on the alkyl group, and this type of it is called as a reaction intermediate or transition state. What it is called as a transition state. So slowly this bond is breaking and this bond is making. Between these two bond is made, and between these two bond is broken. Okay, and finally there is completely bond is broken here and complete bond is made over here. Okay, so these are very important. 3 degree In the 3-degree, iodine will go to, or halogen will go to 3-degree carbon. Okay, but when 1-degree, 2-degree alkyl groups are present, lower alkyl iodide is formed. See, here this is methyl 1-degree, ethyl also 1-degree. If they are 1-degree or 2-degree, iodine will go to smallest possible, ethyl and methyl. Iodine went to where? Methyl group. Okay. So, but when excess HI and temperature is high, okay, when excess HI and temperature is high, what it will be, that I am going to explain now. Okay, now let us see the next condition, next example. Okay, so it is ethyl alcohol plus HI. Now same way, what is that? Lone pair will be donated and I minus will be formed. This step will be always same. Okay. Then the ICH2OH, this part I am talking about, ICH2OH, I will be attacking again. Okay. Always it will attack on the carbon atom which it is attached. See, not this. Okay. This iodine is not attacking on this one. This iodine is attacking on CH2 only. Okay, then this H2O will be lost. Okay, then it will form CH3 CH2I. Okay, in case of tertiary alkyl group, SN1 mechanism will follow. In case of the this transition state in the haloalkane, I think you have studied transition state you will find in the SN2 mechanism. But if tertiary, what I told you, iodine will go to tertiary carbon because that time SN1 mechanism. In an SN1 mechanism, stability is more. What is more? Stability of alkyl halide should be more. In that condition, directly 3-degree carbocation. So this is more exception are more important. Okay. Why? Because 3-degree carbocation is more stable. Okay. Except 3-degree carbocation, in all condition, iodine will go to the smallest and remaining part will go to the largest. Okay. Is that clear? Okay. After the 3-degree carbocation, you have to remember. Once you remember the 3-degree carbocation, okay. In 3-degree carbocation, we have studied that iodine or halogen will go to 3-degree carbocation. 1-degree and 2-degree, iodine will go to the smallest one. Iodine will go to the smallest one. Third case, we are going to check. In case of this is aromatic, this is aliphatic. Okay. So then definitely iodine will go to methyl. Phenol will always form. What will always form? Phenol. Why? Because phenol is the more stable. Okay. Phenol is the more stable. And even though you send any amount of excess HI, it will not react. It will not react further. Okay. So total 3 condition, 3-degree carbocation, 1-degree, 2-degree and aryl. In case of the aryl, phenol will be definitely formed. Okay, phenol will be definitely formed. Okay, next example, next property. Okay, in this complete chapter again and again I am telling you Williamson synthesis reaction with HI. You can check with the previous exam questions also. Then coordination complex, see here, boron trifluoride is Lewis acid. Already I told you R2O. Ethers are what? Lewis bases. So it will donate and it will accept. See, lone pair donated by our ether, accepted by our boron. So then this will form as a addition product. What it will form? It will form as a addition product. Okay. Next, Grignard reagent. Grignard reagent, very important. Few years back, 1 year back, I think, it was there in the KVPY. Okay. So this is lone pair will be donated to the magnesium RMgX. This is our Grignard reagent. In the Grignard reagent, magnesium will be acceptor. Our both donor atom will be lone pair from the oxygen. Okay. And here it is, see here. This is the magic of the chemistry. If I write concentrated, that is removing. But if I write diluted, that is adding and we are getting back our alcohol. This is from where we have prepared and this is the person who was available. But that time sulfuric acid was concentrated sulfuric acid. Now sulfuric acid is dilute. Okay. Dilute sulfuric acid converts ether into alcohol. But alcohols are converted to ether by using the concentrated sulfuric acid. That is the change. See, reagent is same, only concentration changes, purpose is becoming opposite. That's why in organic, what we have to be very careful. What is written on the arrow is very, very important. Okay. Now let's see the next slide. PCl5. This is also I am going to tell you the technique and don't tell it to anybody. Okay. See here. Okay, this is a slide and I will tell you the technique, but don't disclose it to anybody. Okay, you will write like this, ROR dash. This is ether. PCl5 structure, I think it is, you are all known, triangular bipyramidal. Okay, so cut like this, RCl, cut like this, RCl. Okay, RCl and RCl, 2 moles of RCl, and what is the final product? POCl3. Okay, you have to Bahubali in the organic, where to cut and how to cut. Understood? Same way anhydrous are, this is called as a acid chloride. What they are called as acid chloride. Again, what we are using anhydrous AlCl3. We have to remove chlorine. Understood? So ROR dash when treated with CH3COCl. So this chlorine will be replaced. This chlorine will be replaced with OR. This chlorine will be replaced with OR. So CH3COOR. So this is what ester formation. Again you will study organic everything almost you will study 2 times. One will be properties, another will be preparation method. So in the ester preparation method and simple haloalkane will be formed. Okay. Now let's see the next slide. What is this functional group called as? Anybody can recognize? Yes, this is called as a acid anhydride. What it is called as? Acid anhydride. So I will disclose the complete structure like this now. This will be the oxygen. Now both side it will be C double bond O. Okay. Then it will be one alkyl group will be here, another alkyl group will be here. So here alkyl group is what? Methyl group. Okay. Now when it is treated with ROR, okay, ROR, then again it will be ester, this chlorine will be utilized here. Understood? Then dehydration, just now we have studied. Here alkene will be formed, water molecule will be left over. And this oxygen will be ethereal oxygen. What it will be? Ethereal oxygen. Okay. Okay, next very important. Short answer question, beautiful question, dark and light. Okay. When same chlorine treated with the ether, slowly alpha carbons will be replaced. See here, first alpha carbon chlorine. Okay. Second alpha carbon chlorine. Slowly alpha carbon will be replaced. But major product will be alpha dash. Minor product will be alpha beta dash. Okay. But if we do the same reaction in light, all hydrogens are replaced. Nothing is left over. See here, how many chlorines were there? 3 hydrogens were there. Here you can see 3 hydrogens were there, but here how many are left over? Only 3 chlorine will be left over. Like that, there will be change in the light. In the presence of light, all hydrogens will be replaced, but in the presence of dark, only one hydrogens will be keep on replaced. Okay. Okay, next one, properties of anisole. Now, whatever we have studied, they are all aliphatic ethers. Now, aromatic ether, anisole. Okay, anisole, when treated with, just now I told you, this hydrogen will be definitely on the oxygen. Okay, phenol and methyl iodide. Then very important here it is, because of the lone pair, it is OP directing. Which directing? Ortho para directing. So here you can see ortho place and here it is para place. Okay, this is called as a directive influence. How you will find out that it is ortho para, how it is meta, that I have done already one lecture. Okay, directive influence. What you will do, you will go to the YouTube and type which came directive influence. Okay, you will get a video, you will, and this will be useful in every chapter. Aldehyde, ketone, carboxylic acid, haloalkane, everywhere it will be available. So directive influence is a very good topic which will be utilized throughout the organic. Okay, now bromine in CS2. Bromine in CS2 will give you the substitution only at ortho and para. One substitution only will takes place. How many substitution? Only one substitution will takes place. Okay, let's see the next one. Okay, detection of peroxide in ether. Sometimes ether might be converted into peroxide. Whether it is present or not, this is done with the help of the ether plus aqua solution. That means if ether is available in aqua solution, ferrous ammonium sulfate, potassium thiocyanate gives the red color. So in our peroxide, ether is there or not, or in ether peroxide is there or not, just add ferrous ammonium sulfate, or you can add potassium thiocyanate. Okay, then reddish color should be formed. There it confirms that ether is present in peroxide. Okay, then diisopropyl ether is also used as an anti-knock compound. Okay, actually there is a rattling sound in the engine when petrol is more not branched, it is a straight chain like this. Okay, so then actually it cannot go and burn in between. So that will produce a sound called as a knocking. Okay, so that knocking is avoided by adding the diisopropyl ether. Okay, then Giselle method is used to precipitate the silver iodide. Giselle method is used to provide the silver iodide. Okay, so this is used in the AGI estimation. Understood? And petrol is mixed with the 1% diethyl ether, and mixture of the chloroform and ether is a general anesthetic. That means you will start losing your control on your body. Okay, so this is about the properties. Now let's see the next. As I told you at the end of this, we are going to study very advanced topic. Okay, oxirane, epoxide. So now the time came. So that is the use when you study right from the basics to the advanced examination through the slides, because nothing will be missed and clarity will be there in the diagrams. Okay. So here you will find epoxide. Epoxide means this one. Okay. 1,2 carbon atom, one corner is occupied by the oxygen. And crown ether, they are actually cyclic polyether. See here, how many oxygens are there? More than one oxygen is there. That's why they are called as a polyether. And the naming, special naming is used over here. So this is the naming 15 crown 5. So this 5 represents carbon oxygen atom 1, 2, 3, 4 and 5. Out of this 15, 5 oxygen also will be there. Only 10 will be carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total must be in the starting. And in the inside the crown, you will write only oxygen number. See here, 1, 2, 3, 4, 5, 6. So crown 6 oxygen atoms are there. and 6 oxygen atom and 12 carbon atoms. So total 18. That's why it is called as a 18 crown 6. Okay. First number indicates ring size, second number indicates oxygen atoms. So there, and one more third part is thioethers. Thio means oxygen is replaced with sulfur. Oxygen is replaced with sulfur, then they are called as thioethers. Okay, note down this. Noted. Okay, now let us go to the next one. Epoxide or oxirane. Okay, what is the IUPAC name and what is the preparation method? What is the cleavage? The questions will be which direction bond will be breaking. The importance of this chapter lies whether I should break this bond or this bond. That also will be explained with the rules. Okay, epoxides are cyclic ethers with three-membered rings. See, one, two, three, three-membered rings. At one time, there will be named as oxide or alkenes. But IUPAC naming is oxirane. Previously, what they are called as oxirane. But nowadays, once they started selling everything, then they started saying it as oxirane. What it is called as oxirane. Understood? Then substitutive IUPAC name. This is also actually uh, here see three-membered ring, but it is substituted with this group. It is substituted with the methyl hydrogen methyl. Okay. Then naming will be like this: 3-methyl, 2,3-epoxy butane, 1,2-epoxy cyclohexanone. Simple, you write that name and previously whatever the carbon are there, they should be named up here. Okay. Noted. Okay, oxirane epoxide. Now let's see the next one. Here, very important. This is called as a peroxyacetic acid. People are thinking that this is carboxylic acid. No, it is. It is CO3H. Here I will write it clearly. C double bond OH is carboxylic acid, but it is R C double bond OOH. So this extra oxygen is called as a peroxy. The extra oxygen is called as what? Peroxy. And very important example is MCPBA. What is MCPBA full form? Anybody knows? Anybody knows what is MCPBA? Okay, here MCPBA means metachloroperoxybenzoic acid. Benzoic acid, peroxybenzoic acid. This is benzene and this is peroxy, COOH. Metachloro, M-chloroperoxybenzoic acid. This is used for epoxidation. This oxygen will directly go to the carbon which is containing pi bond. Now this is called as a what do you call para, epoxy. Okay, so this process is called as a epoxidation. Same way here double bond is there. So in this double bond you will find oxygen. Here double bond is there. Here you will find oxygen. These are the oxidizing agents. Very important this one, but not for the simple exams. It will be for difficult examples only. Okay. Now let's see the next. Properties are very important. Breaking of that pi bonds is only main questions. Epoxidation of alkenes with, we have done RCOH, always syn addition and anti-addition. That I think you have studied in the reaction mechanism. Otherwise, I will tell you syn addition. Okay, See here, this is the cyclic. Oxygen will go and attach here. So there will be cyclic. Okay. So this is the cyclic ring. Both methyl group on the same side, both hydrogens on the same side. This is called as a cis dimethyl oxirane, and it is a meso compound because of the POS, plane of symmetry. Those who are having doubt about the stereoisomerism, it is specially done. What is meso, what is diastereomer, what is raceme mixture, that is clearly explained. Okay. Same way here, methyl and methyl are opposite, and here after the reaction also see methyl and methyl are opposite. Syn means trans will remain trans, cis will remain cis. That is called as a syn. Okay. So here opposite side this is trans. Understood? But addition is syn addition. Syn addition will keep the same thing. Initially if it is trans, after that also it is going to be trans only. Okay. Now let's see the next topic. Competition tips, very important. There will be order of increasing order of epoxidation. Okay. See here you will find two methyl groups here, one methyl group here, and here two methyl group and no methyl group. More number of alkyl group, more will be rate of epoxidation. Arrange the following in increasing order of epoxidation question comes. That time you will answer like this. Okay. So don't lose interest. Some more important, some few important points are I am going to tell you. Okay. Now let's see the next. Base catalyzed vicinal. Base catalyzed vicinal chlorohydrin. Chloro means chlorine, hydrin means OH. See, one side it is chlorine, another side it is OH. Okay. So this is not chlorine. This is called as a chlorine water. What they will write? Chlorine water. Chlorine water will give you the chlorohydrin. But if you further use the base, then obviously base what it will do? It will remove the H and Cl. Acid it want. HCl will be removed, then this will be forming as a cycloether epoxides. Okay. Then this method can be used for 5 to 6 membered ring also, but it will contain heterocyclic. See here. This is will be removed and fifth carbon oxygen atom will be hide. And very important solvent. You will know this, but don't know as a full name. THF, tetrahydrofuran, is an excellent organic solvent. It is an excellent organic solvent. Okay. Now let's see the next slide. Epoxide properties. Very important, cleavage of ethers. Okay. So if I do the H plus, okay, the reactions either involve acid or in the acid catalysis. Okay. H plus, in presence of H plus, definitely this lone pair will be donated to this H plus and this is positive. So this bond will break and the with H plus suppose Cl minus. So example of Cl minus is Z. Okay. Z is a nucleophile. It can be Br minus, it can be H2O, it can be alcohol. Okay, now let's see the next. So these are the some examples. There is Z I have taken. Here Z is bromine, here Z is C2H5O, here Z is OH. So this is the best method to prepare vicinal diols. Vicinal means adjacent, di means two, OL means alcohols. Okay. So this is an example of vicinal diode and acidic conversion, acidic cleavage of ethers. Noted. Now let us see the next heading. Level 2 concept. Acid catalyzed ring opening of unsymmetrical. Earlier there was no problem. But here it is, one side it is dimethyl and another side it is CH2. Okay. So the nucleophile attacks primarily at more substituted. So this is the more substituted, this is less substituted or not at all substituted. Okay. Then this nucleophile means H plus will attack where? Here. Okay. More substituted atom. How it is going to attack, that I am going to explain through the mechanism. Explain through what? Mechanism. Okay. So this is the mechanism. Attack of nucleophile on the more substituted carbon atom is because such atoms of the protonated epoxide occurs considerable positive charge. This is positive charge and resembles like more stable 3 degree or 2 degree carbocation. So now it is just like a 3 degree carbocation. Then it will lose again H plus, then it will convert back to the alcohols. Okay. And this mechanism is SN1, just like SN1 mechanism. Now let's go to the next slide. Alkenes can be easily converted. This is a previous question sentence taken. 1,2-diols followed by hydrolysis. First what we will do, alkenes are converted into diols, then on epoxidation by hydrolysis. These are stereoselective and reaction 1,2-diols are formed in anti-addition. In the previous type, we have studied syn addition. Okay, carbon-carbon double bond similarly with hydroxyl oxidation. Peroxyformic acid. Peroxyformic acid is HC triple bond, triple oxygen OH. But with different hydroxylation, then permanganate or osmium tetroxide will give you the syn addition. Okay. Let's see. Base catalyzed. In the previous what we have started with H plus. We have started with H plus now, but here it will be base. In presence of that, this will be. Unlike ordinary ethers, epoxide can also undergo base catalyzed, provided attacking of nucleophile should be strong base. This is alkoxide is a strong base or phenoxide ammonia. Attacks at the less substituted. There H plus is attacking at less substituted and here RO negative attacks at the less substituted O negative and again this H will attach here, RO negative will be given back. Okay. This is the acid and base catalyzed ring opening of ethers, cyclic ethers. So these are the some examples: RCONA, NH3 and thioether. Everywhere you can see there will be alcohol formed. Okay. You can draw it and practice. Okay, now let's see the next. Cleavage of ether by Grignard. Only one more topic is there. So let us finish off it fast. Cleavage of ether by the Grignard reagent. This is again to increase the number of carbon atom in the conversion. Suppose they say convert propane to pentane. Then this is the best method used. Okay. So here C6H5 MgBr CS3O CH3. Okay. So simple here, one part, this will be converted to alcohol. This C6H5 will be attached here. MgBr and HOH will be eliminated. Actually, HOH will be there. H will be here and MgOH-Br will be eliminated. Okay. This is also regioselective because nucleophile attacks at the less substituted. Again, it is less substituted only. That is called as a regioselective. If you don't have idea about regioselective, then I will explain. Okay. So in this reaction is used for preparation of alcohol having at least 2 carbon atom. Okay, because our Grignard reagent also will have the 2 carbon atom. But epox are reduced to alcohols with the aluminium hydride, lithium aluminum hydride followed by hydrolysis. Okay, crowded carbon. Okay, thank you for watching Which Chem. Keep visiting, keep studying and keep rocking in your examination with the highest possible marks. Okay, so I think all of you will start the practice session of the ethers so that you can, whatever you have learned in the theory session, will be able to apply it.